If you're ready to harness the power of your communications data, blast off with Nylas today.
Hello and welcome to Coding with Nylas, the live stream where we talk about programming, APIs, and more. My name is Blag, Senior Developer Advocate.
And my name's Ram, Developer Advocate at Nylas.
How are you today, Ram?
Oh, I'm doing good. Excited for this live stream, but I'm also all over the place. So I'm glad we get some time to do this.
Yeah, we have been pretty busy these days. We're running a hackathon, so things get messy a little bit. Well, let's go. So today we're going to talk about an introduction to the Mojo Programming Language, which is all over the place. Everybody's talking about it, so we're going to see what it is like. So first, don't forget to like and subscribe. Give us a thumbs up, like our videos, click on the little bell to get notified, and most important, subscribe. So the more subscribers we have, the more videos we can do. So let's jump into it. So what is Mojo supposed to be? So it's a Python superset with the memory security and speed of Rust. So that's what they claim. So they said that it's 35,000 times faster than Python, which is okay. Probably means that's what they say. I haven't been able to test it in that proportion, but I mean, it's like, okay, execute it. So I don't know. Basically, what they do supposedly is they leverage the multi-level intermediate representation, the MLIR, to take advantage of vectors, threads, and AI hardware units. So that's why supposedly it's super duper fast. So basically, you can go to modular.com /get started, and you can actually ask to be included on the playground. So right now, you cannot download Mojo onto your local machine. You need to use the playground, which is a Jupyter notebook, to do whatever you want to do. So what we're going to do now, I'm going to share my screen. I have access to the playground. And I have other things open here. So here's the playground. So the nice thing about this is that you can execute Mojo, but you can also execute Python code. So we're going to do a little bit of a comparison. So first, we're going to do this Fibonacci. So let me see if I can make these things a little bit bigger. How can I make this bigger? Just like this? Yeah, probably. So, okay. So to run Python code here, we need to put these two percentage signs, then Python, and we can declare our function like regular Python. So here we're just defining a Fibonacci function. So let's say we say 5. It's going to print out 0, 1, 1, 2, 3, 5. Right? So the number, gets some from the other two. So let me put this here, for example. Let's say we said 5. It should print out 0, 1. 0 plus 1 should be 1. 1 plus 1 should be 2. 1 plus 2 should be 3. 3 plus 2 should be 5, and etc. It's always going to grab the last two numbers, add them together, and then generate the next number. So here here we cannot actually ask for a number, so we just declare a variable, and let's say 10, for example, and we're going to pass that into our function. So this function basically is going to say is the first parameter, which is 0 here, is actually 0. We're going to put 0, 1. We're going to sum both. So it's going to be 0, 1, 1. And then we're going to call the function again. But this time we're going to decrease the number. So num minus 1. We're going to have 9. We're going to pass the sum of these two. So 1. And then this 1. So here I'm just going to do a comparison. And it's going to be summing the numbers, and it's going to generate the string. So if I click here, run. Okay, here it is. So I said 5. So 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. So this is the way we do it in Python. Let's see how we do this in Mojo. And keep in mind that I'm not a Mojo expert. I just kind of like started, so it might be a little bit weird. So first thing that you're gonna notice is that we actually need to import a string, and you would like, why do we need to do that? Because Mojo have strings, string literals, string references. So a string is not actually part of Mojo, so you need to import it like an external library. Then something else that you're going to notice at a first glance is that we're using here fn instead of def. We can still use def, but the nice thing about using fn is that you actually need to do something like this. So you need to say the type of the variable you're using. So here, if we look at Python, we just said num a b. Here in Mojo, it's going to be num is an integer, a is an integer, b is an integer, and we actually going to return a string. So that's something completely foreign to Python. This is something that you can find usually in functional programming languages like Haskell or Erlang, or even Kotlin, but not in Python. And also you're going to see here that we're actually using a var to declare our variable of type string. So here we can use var for variables that are going to change in time, and we can use val for variables that are not going to change, so they're going to remain constant. Also, you're going to see we cannot just concatenate the strings like using a plus, like usually you do. So what we need to do here is going to say result, and we're going to have this double underscore function add, and we're going to add a space, and then we're going to sum a and b, convert it into a string, and then add it. And then for the next one, we're going to pass the Fibonacci so we can do some sort of recursion. Here it gets even messier because here a will first convert it into a string, and then we need to do a lot of adds just to add the space, add b, add another space, add the sum, and then finally add the call. And we're going to return the result, and in the very end, it's going to be almost the same. Here, I'm not declaring any variable. I just pass in 10 straight. So if we run it, it should be exactly the same. It's a way different syntax than Python. So what do you think so far, Ram?
I'm looking through this, and one question I have, maybe it's good to reemphasize the purpose of the string is just for the result.
Yes. So here we're saying that the result of our function is going to be a string. And this is good because it enforces that, for example, and here also on the parameters, we're specifying the type. So here, if I would say, like, for example, 0, which is going to be a double, it's going to complain, like, hey, I actually need an integer. Or if you pass like a string, it's going to say, no, I need an integer. Also, if instead of printing this, I would do something like, let's say, by bar my num, and let's say 0, and then we go like my num equals fib. This means that we want to put that result into my num, which actually it's an integer. Then what that would mean is that it's going to complain because it's going to say, no, your function needs to return a string, and it cannot return anything that is not a string. So that's going to make that our applications or our programs are more robust, and it's going to allow the compiler to catch errors like more easily.
Yeah, so this is something I've seen the difference between JavaScript and TypeScript. With TypeScript, everything is it's recommended to be type, where your arguments are all type, the return is type, and it just improves the program, your code as you grow your code base. Because once everything plugs into each other, you can see if you're using a function incorrectly, or if another developer builds a function for you, you can see if it's actually going to integrate with whatever you're doing.
Yes, exactly. Yeah, so in the end, it's way better. You could, here on Mojo, you can still use the def and do it like the Python way. But I think this is way better because it's enforced that you actually pass in the right variables and that you're returning the right value. So it helps a lot when you're doing debugging on something like that. So that's for the Fibonacci. Let's gonna close this because we have another example. I'm just gonna discard that. So this one, and I hope I open the right one. No, I open the other one. So this is one of my favorite codes of all time. Basically, you pass a number and it's gonna return it like in LED, like in all clocks, digital clocks. So basically, what we have here is just a dictionary. So for every number, we're gonna have here how the number is gonna look like. So for example, 0 would be something like this. And it's kind of hard to do it like this here. You get the idea, right? So it's gonna be something like this, and it's gonna look nicer when I execute it actually.
So just for reference, I think every time, maybe I don't know if everyone watching knows this, but anytime you learn a new programming language, this is one of the code samples you build out an LED.
Exactly.
Okay, cool.
Yeah, I have done this like, I don't know, like 75 different languages or something like that. So basically here, what we're gonna do is we're gonna go in a range of 3. So first line, second line, third line. So as you can see, this is divided into 3. And here, we're just gonna say, for example, if we have 1977, grab 1, which is gonna be this one, grab the first part, then go into 9 and grab the first part, then go to 7, and then do the same, but with the second part and then with the third part. So in the very end, you're gonna start printing the 3 lines, and that's gonna give you the result. So if I press play here or run, it's gonna run and it's gonna print it like this. So 1977, like in digital format. So this one, if we do it in Mojo, this is something kind of funny, because here you don't actually have a dictionary in Mojo, at least not right now. So what you need to do is you need to import Python for the Python interface, Python object from Python object, so that you can actually create a dictionary. So right now we're using Mojo to interact with Python. So we're creating a Python dictionary that we're going to use inside our Mojo application. So here, we're going to declare a string. And actually, you see that we actually need to say this is going to be a string, because otherwise it's going to be a string literal. And sometimes a string literal cannot be used as regular strings that we use in other languages. So we actually need to transform that. Here it's going to be almost the same. We're going to have a range. Here, what is going to change probably a little bit, we need to do the add, to do the concatenation. This atoll, it's going to transform a string into an integer, so that we can grab here, let's say, for example, 3, and then grab this one, this one, this one. Everything, we need to convert it into a string, and then we can print it out. So it doesn't look that much different, but there are some things that are kind of different. And then 1977 is going to be printed. So this is kind of the same. There's not much really a difference between these codes. But it's funny that you actually piggy bank on Python to get dictionaries. So the last one, and sadly, this one is not going to work as I expected or if I wanted to. So let me see. So I open the right one. So this one, what it's going to do is going to create 2 arrays, one with 15 names and one with 15 last names or surnames. And the idea is that we want to loop 100,000 times. And basically, we want to concatenate the name and the last name and put it inside an array. Why? Just to measure the speed. So 10,000 100,000 times, concatenating two random names and last names, and then putting that into an array. Here you can see that I'm just putting it into a string, and you're gonna see why when we jump into Mojo. So obviously it's gonna be fast because we saw the arrays kind of fast, but still we're gonna compare how it goes with Mojo. And the good thing is that we're executing both codes on the playground. So it took like 0.12 seconds. So pretty fast. Now let's jump into the Mojo one. And you're gonna see straight away the difference. So here we're actually gonna use a vector or vectors. We're not gonna use arrays. We need to import the random library, the string library, and the type. So here what we're gonna do is we're gonna declare a dynamic vector, which is gonna be the type string ref. So that's a reference to a string, kind of like a pointer. And here we actually need to push back every single one. So I haven't found a way to actually do it like in Python. Like when you declare your array and you put everything, here is like one by one. So the code is obviously bigger. So I have one for names, another for last names. And here I declare another dynamic vector, allocated 100,000 elements. And that's kind of like our array. The problem here, you're gonna see, we're grabbing and we're getting a name. So we're getting the item. We're doing a random number between 0 to 15 to grab one of the names. We're doing the same with the last name. And the problem here is that when I wanted to add it into this vector, it wouldn't allow me, because it complains that it's a string that needs to be changed into a little string, but then when you put it into the vector, it needs to be a string. So it's something complicated that I haven't been able to figure out. So there's need to be some sort of conversion that right now you cannot do that easily. So sadly, we're not able to see the real example. So if I put that, then actually I try to put it here. Here on the child. So you see that it actually, it's going to say string literal. You cannot construct a string literal, from a string. So basically, I wanted to do this. So do a pushback every time. It just doesn't work for whatever reason. So still, we're going to run this, and we're going to see how fast it is compared to Python. So it's actually 0.02. So it's faster still than Python. So Python was 0.12, and this one is 0.020. So it would be nicer if we actually had arrays, because that would be able to do a better comparison. But still, we can see that Mojo is way faster. So that's nice. And actually, this took me a lot of time. There's a really nice page called mojodojo.dev, but there's a lot of questions and answers and examples and guides and everything. I relied on this a lot to be able to build those examples, because the community, the Mojo community right now is not that big. But still, there's some nice things that you can do. So actually, let me, before we go, try to run something so we can say. So this one is Mandelbrot in Mojo with Python plots. So there's a lot of code. But look at that. Pretty nice. So you can vectorize it. So there's a lot of examples here on the playground. You can parallelize it. I think one of the things is that right now Python cannot use more than one core. And that's something with the GL, the global lock. They're trying to take that out. But with Mojo, you can actually take advantage of multiple cores. You can do, you can generate way more speed. So that's one of the cool things about Mojo. So stop sharing my screen. Kind of what I have for Mojo. I think it's pretty interesting, pretty fun. And we actually are like 20 minutes, kind of like over our time. So let me just remind you that live streams go every Wednesday and Friday at 2 p.m. Eastern Time, 11 a.m. Pacific Time. Something you want to share, Ram?
Yeah, just quickly want to share that we have an upcoming workshop
Cool.
tomorrow, actually. So for this workshop, you can actually follow along and watch myself build an email responder with generative AI. So the idea here is that you can actually start using the Nylas quick start guides and the Nylas SDK and as well AI to start building an email responder. So this is going to be on Thursday. We're going to have a virtual workshop. So build an email responder with generative AI in Nylas, and you can go ahead and sign up at nylas.com /events. So you can go ahead and check that out. And as well, this will be useful for our ongoing hackathon to kind of get started with building with Nylas.
Yep, and remember that you can go to nylas.debpost.com to sign up for a hackathon. You're going to get a nice email with a lot of resources. You're going to be able to create your free Nylas account, and you're going to be able to participate on the hackathon. So before we go, just to remind you to like and subscribe. Don't forget that. And for this Friday, we're going to talk about a recap on our first week of the Nylas hackathon. So just some basic statistics that we're going to share. So try to, again, go to nylas.debpost.com and join the hackathon. We would love to see you there. So thanks for being with us for so long. We actually have 2 comments, which is nice. Okay, so thanks for the good topic. Thank you so much. I'm glad you like it. And we have some hearts as well. Awesome. We love to have comments. That's great. Thank you so much. So see you Friday. Thanks, Fran.
All
Take
right.
care.
See you.
Everyone.
Bye, everyone.